How's it going, everyone? Welcome, Eulier Gonzalez here. So in today's video, I do want to look now at the data fetching point as well as the memoization, and also I want to do a quick recap of how do I get here, because that will explain so that'll make sense of how do I get here, right? So this is a course taught by Josh Komua, a software engineer that previously worked at Gatsby and before that at Khan Academy. So those websites were the first, or at least Khan Academy was the first to use React in a scalable way. So based on his experience, it create actually this particular course to outline is not only the history, how do we get here, which is part of the reason of why I'm doing this series of videos, but also is a more practical sense, because I have realized, and this is something that is not new for a lot of you folks, that doing is caring. And when you do something, you actually understand that. So the TLDR of this is that React at the end of the day was to solve a specific problem. And that is, how do you now have a single source of truth where you can have, or when you can synchronize with the UI? Why this is it? Well, it turns out that in the traditional way of developing web applications, when you have the client and the server, first you have is the pattern to build these applications, like model, view, and controllers. So each one of those models are bind to the controller for doing the data treatment that is going to be used in the view, and eventually show that to the user when it navigates to a particular route. So for example, in this case on the joy of React, in the traditional way of doing this, you might have is one single model that represents the data that you are storing on somewhere else, usually a database. Then you have some data treatment on the controller to populate or to hydrate that on the view, which is the HTML here. So because this particular way of doing things is quite cumbersome, especially when you have now models that have some shared states, all right? And in the case of Facebook, they have an issue particularly with the how they displaying is the notification for message, and well as the chart message, or the drawer menu. I think we can actually take a quick look at that. I'm not gonna dive too much into that. Just the image like this, right? So they have an issue is with the message icon or the message drawer, the chat widget, and the main view on the chat. So how they can synchronize this piece of information across different user elements. Again, the traditional way to do that is you have for each one of those elements is a model attached to. So with React, it's a, hey, let's go to leverage over the past 50 years of software development and programming to now have one single source of truth, which is our state, that'll be managed by React, this JavaScript library, so we can now sync our UI according to this piece of information. So this has shown very dramatic and powerful development, and also entering into a new way of developing applications using React that is so convenient, because not only that you are able to provide more interactivity to your users, but also the idea to synchronize that particular information across different UI. That's the whole point of this. So they move this not only from the web, but also on the mobile with React Native. And because of this, and also for the WebLG, but because of this way of developing applications that, again, in the case of the web, they are using is HTML, CSS, and JavaScript, okay? But now this is this particular way of developing web applications in React, okay? So this is why here we look at understanding is the anatomy of the React, and also is how you can create a project on React. And by the anatomy is, hey, see what React is doing at the end of the day, which is creating an element and is creating an HTML element and add a nice little wrapper around this. Because that can be quite tedious anytime that you want to create a particular HTML element. We have now a markdown that combines HTML with JavaScript, known as JAX. So that's great because we can start to see how you can develop this small user interface using the component applications and so on and so forth. And because now with JAX, it has to pass through a compilation phase, or particularly known as the transpilation phase, where you're going to transform that into something that is meaningful, in this case for the JavaScript engine, the browser, which is JavaScript, right? This is what we have the notion of the transpile and the compile here, okay? And well, get yourself familiar with this syntax in terms of how you define your components, what is the difference, how you define your HTML tag, what is the difference between the regular template or HTML versus JAX in HTML4 attributes, in class name, and also how you define is events in this markdown, right? How also you can add some logic to this, and the comparison between template and templated language versus JAX, which it doesn't require you to have is its own templated language, like the for loops or conditionals. You're already using JavaScript to do that. That's why we have is this JAX, and how convenient it is. So and also some gotchas, like for example like the white space gotchas, and how you can use that. And then now see how you can create your React components in this component way, which is JavaScript functions, and how these things actually works. What is the anatomy of these components? You can pass some props or some props to this. You can also render those props, and the children's property that is part of the HTML that allow to these components to render is all of the other additional content. This is pretty much like on HTML. You can render now nested content, okay? And how you can actually is working with props, the children props, and how you can provide now a style to this component, right? They say exercise CRM, which is with the contact here, but how you can provide now a style to these components, and an additional components like the fragment, and now how the application structure would look like, right? Because you're not writing HTML, CSS, and JavaScript. You are now combining all of this in a React way, right? So this is why we have now here is the index, which is the entry point of our application. This is when we do stuff like adding the CSS and attach our React applications to the DOM. And then you have now the app file that describes the React app home. This is where you define your providers, your context, and some top level React components where you can have your own logic or your own UI again. And last but not least is the model, is the component, is the filing in itself, right? How you can use now fragments to actually iterate on or to render now a list of elements, which is most of the time what we do on web development. How convenient it is for us to render those elements using is the existing JavaScript array methods like map or filter or find, right? Some of the gotcha with parentheses and some of the gotcha with parentheses and curly braces. And they mention here is what is inside of JavaScript, which is inside of JavaScript. GS inside GSX, inside GS, inside GSX. I think we have add this comma here, right? And how now these rendering elements actually look like behind the scenes. So because this is a React element, it's going to say, hey, I'm gonna create now another list that it is children will have now rendered this list of elements, which anytime that you see a HTML tag on the GSX, it represents is a React element. In other words, a React create element function like this. So with this understanding, and also how you can tell React that this is a unique values by putting is the key when you iterate on some of those elements, and also how you can conditionally rendering elements here, whether it's using the if statement for early returns, this is useful for errors handling, or the using the ampersand or using the and, how useful is to do that. For example, if you want to show now the components instance or not, based on a logic, or if you want to show, for example, is an if else statement at the template using the ampersand, right? So with that, all right, which is to cover the most common use case, as well as how useful for us is to use now a range utility to render is dynamically an array of elements. Right now we can use is the array.from, so array, and specify is this dimension of this this collection, and what do you want to fill with here. So this is a way of how you can dynamically generate is a collections, right, using built-in tools like JavaScript, and also some of the styling that I mentioned before, which is relying on CSS in GS, which behind the scenes what it's doing is just to attach a series of prefix to that CSS, the CSS rule name. So in other words, this CSS model tool is creating is a long CSS rule name made of the several components. So for example, the component names, and the app name, the component names, and also is the name of that class that you want to use in your React component. So all of this is the model one. And then on the model two, we went through understanding now is how do we respond to events in React, whether it's by, how do you respond events in Jesus. How do you respond to events? How do you handle events in HTML, CSS, and JavaScript, right? Whether it's by listen to an event at a tag, the HTML tag, or by adding an event listener or a global event listener. But the way how you do that in React is by passing as a functions reference to that React element that is up to that. When the user trigger that state change, React will call your function for you. So this particular mechanism, which Martin Fowler, one of the software engineers that was part of the Agile Manifesto, and he's currently working at the ThoughtWorks, which is an IT company headquarters in Boston, that they host a technology radar to show us these platforms, language, tools, and techniques used on the software industry, right? I really recommend that tool. Is quite informative, illustrative. I'm not gonna dive deep in today's video, and this is something that he mentioned, that and what actually makes the difference between a framework versus a library, right? So yeah. Now, the way how do we do that in React is by passing now functions to React. In other words, via the JSX. So React is going to call the functions for us when the user trigger that event. Okay, so because this way of providing interactivity, here I also look at how to do that by hooking to one of those hooks, you might think, of React, which is a use state, which allows to store a piece of information that will trigger a rendering when we update that information. And the way that it works is you define your state via the React library with a particular piece of information, whether it's a primitive on the final number, boolean, strings, and also big int, or with a complex object, whether it's a function or whether it's a function, an object, or an array. So for primitive values, there is no mystery here, right? You update your state when the user trigger that action, which is inside of this event handler, all right? And when it comes to update now complex data, arrays and objects, it is always useful to return is the new state for that. The reason for that go beyond the scope of today's video. That's actually quite interesting in order to understand now how the language JavaScript actually works. Then, all right, how now can we update data or what happens when we update a data uh, using an state. Well, it it triggers now something called as the core React loop, and this is that when you update, when the user trigger an event that update the state, and that state that you want to update is whether it's a primitive value, all right, that represents something. So for example, you want to represent here in your bank account or here in this Word app, right? You want to represent is a title, right? You might want to store this piece of information as a string, all right? Or you want to represent more complex stuff to say, hey, I want to represent each one of those collections of actions that I can do. So I might use is now an array for that. In each of those cases, when you update that state, so for example, when I do this, right? And as you can see, it actually show here and triggers this, right? So when you enable that, or when you, for example, change this, right? So in the case of React, what happens is that it's triggered this core React loop that say, hey, first I'm gonna detect it is made of two stage. This is on initial load or when the components re-renders. On the initial loads, what it's doing is, hey, it's going to mount the entire applications and let me append that elements into the DOM once I create all of these elements. And when a re-render happens, meaning is that when the user now trigger an event, once the application is loaded, it go to, I first identify the component that triggers that state update, then it's going to render, or an AKA is going to run that function, and at the end of the day, it's a JavaScript function that represents is a React component. And if that React component contains more elements, more JavaScript function, more React elements or components, you're gonna continue to call them until there is no more components. And when you do that, behind the scenes, now it creates this virtual DOM, or in other words, it's creating now a representation in a JSON-like object of that component that describe is the state of that UI. And it's going to continue to do that for all of the React element that it finds along the way. So once the React have now this new representation of the DOM, known as the virtual DOM, then it goes to update is only the it's gonna update with the necessary change the DOM, and when the DOM updates, it triggers now a browser paint that actually match the UI at that desired state. So this is known as the core loop. And when you are able to understand and describe that and see that in actions, it actually clarifies the mystery around this. So that's actually the model 2, right? In how now in model 2 we talk about is, which is here, working with the state, right? Understanding that particular core loops, how also you can now is define some forms. What is the most common thing that we do when handling forms, whether it is input text, password, input text, password, or email. How do you also now retrieve some information for this input, not only input text, password, or email, but also for select, and also for radio buttons and check boxes. And because with HTML, there is not a consistent interface to retrieve data and to update that, known as the two-way data binding or this data binding. So React now creates a convenient API that allows to interact with it via the onChange and update the value here. There's a couple nuance, because when you do that on checkboxes or radio buttons, you actually have to update is the check property. This is for single checkboxes or radio button. But what happens when you have now multiple of them? Well, you do need to have is the represent that into a group using the named to group those radio bar checkboxes or radio button. All right, so they now belong to the same section, sort of speaking. Also, how you can work with props and state, and as I mentioned before, how you can work with complex states when updating your state. Avoid any mutations. Always generates a new state of that. How you can dynamically generate unique values using crypto UUID, and also how you can now put the state in a place where it makes more sense to share that data, right? So known as the lift state up. And when you have now complex piece of information, right? Like handling tons of data in an app. For example, for landing page like this, or for landing pages, you might want to have is small piece of information in each component, right? But if you're building now something that have a lot of interactivity, right? You might rely is on a Redux instead, which allow you to handle and to coordinate and keep track of all of this state change. For example, heavy client interactions like some games, or when you do need to have a lot of interactivity in that web app. But now, if the piece of information now live on the server, then you have a different challenge. That is, hey, how do I now fetch the right data at the right time? How can I catch the response so it doesn't grow stale, right? And also, how do I avoid how do I avoid bombarding a couple of things, sorry. First is how do I care about getting the right data at the right time, and how do I now find a way to catch the response data? How can I prevent firing up this request over and over and over? And how might I make sure that the data at the client side doesn't grow stale? And how can I get a piece of information or a slice or a pagination of that data and to show that to our users, right? So all of this are challenge that are describing here and working with states, all right? And some of those challenges are part of, so you can split those challenges by client-side state or landing page states, heavy client applications, or server-side applications like that. So all of them now have a different set of tools. So whether it is React, if you want to manage a lot of this piece of information, or React to manage a lot of this piece of information. The other is the yeah, React for managing all of this information, Redux, sorry, and when it comes to creating SaaS app, server-side rendering applications, most of this data live on the server. So now this involved is the network issues. This is why we have things like Apollo client server, or which is built on GraphQL, or useSWC, SWC to handle those network related issues. In And that's great because finally it helped us to be where we want to be here at this point, right? Which is, hey, how can I now look at the different hooks that React provide us? So because traditionally we have React components that allows to create is UI as well as piece of information that we want to share across our entire app, because that was the only tool that we have available to solve that needs. We overuse that, and this is what we have here in some of the React app, all of these different nested components. So the React teams came here and sit around and say, hey, there will be a better way to handling is the effects. There is a better way for us to handle is this logic composition, all right? And that is hooks. So we have now several of these hooks. So one of them is the useRef, where it allows us is to store some piece of information, usually is a DOM, that live outside of the rendering, so it doesn't trigger a render update. It is preserved, and the most common use case for that is for focusing elements when the component is mounted, or for grabbing a video or a canvas and then interact with that element when we need it, which is great as well. That's most of the time is what we use ref. And also with audio tags, another hook is the use ID, when you sometimes need to have some global identifiers, right? So for example, is if you have a form and that forms share similar IDs or group name, you don't want to actually mismatch, or you don't want to mess up with this form group. So for example, you have a form with several radio buttons, let's say form with different pixel stuff, or pixel selections like that, or you have another form in the same page but for topping selections, right? Using now checkboxes or the same radio buttons. But the point of this is that with use ID, anytime that you need a global unique identifier, React generate this for us. Okay. And then the another hook, which is the use effects. So anytime that you need to run things after a render happens, or when a component is mounted, right? This is how you can now synchronize is React state with outside state. So for example, this is useful for synchronizing is the navigation on that case, or the if we are online or not, if we are connected to a remote server or not, or even if we are listen, or if we have now, for example, or if we are detecting mouse move, which is one of the very beautiful examples here. If you're detecting global events, right, or you want to synchronize with external events, or you want to run some network calls, so for these cases, a use effect is useful, and it has certain rules, right? So use effect, it say, hey, I'm gonna run after every render happens, and I'm gonna run this piece of code, and it can be is on the initial load, or when on the initial render, or it can be, so it can be, so I can run this script is anytime that the component's mounted, all right, or anytime a reactive dependency or some variable known as reactive dependency change, or only once, all right. And why do we give it? And what do we even care about is the cleanup function. So here in the cleanup function, sometimes we need is to, for example, is deregister global events, all right, or stop listen for a connection. So in those cases, running the cleanup function, which is returning a function, is when you define is what do you want to do here. And there is also a notion of the stale values, right? This stale values is something that I put it here and I didn't mark that, is that sometimes because the notion of this is that an effect is run. So the notion here is to understand is the components instance, and the that's the whole point of this. Because I look at this. So the whole point of this is to understand, is to know. Let me see if I get this right. Stale values here. Exactly. So, but the whole point of this is to understand the life cycle of the components instance, as well as the use effect, and when it runs and how it runs. But it's to develop these notions around this. Okay, so when you run now use effect, sometimes it can be quite out of sync if you don't pass an array of dependencies to the use state, to the custom hook, to the use effect. All right. And also how you can actually pull data from the components instance, so you're guaranteed that you always have the latest state of data. So that's a very interesting things to explore, and the same for state setter. This stale value is also true for state setter callbacks. So anytime that React provide you a hook that it needs to keep track of dependencies, it's a hey, you can is so this piece of information can grow stale if you don't provide the array of dependencies. So I do not know what will be is the fresh value, or I can put that value from from the components instance. In other words, where am I using this? So for example, here is actually pulling the data from the components instance here. And I know that, that I recognize that this is confusing as heck, right? So why not always use the callback syntax? Sometimes you might, sometimes you don't. But the idea is that to develop the intuitions of how to work with, so why stale values happen, and how you can work with the components instance. So the idea is to understand is the notion between is the component instance that you can pull data, fetch data from that, or the or for that particular hook, right? Whether it's a use state or the use effect or the use callback and use memo. And if I read here, so this is a typical counter app, right? There are no effects, not asynchronous code. There is no way for the state to grow stale, at least in this case, right? Why there is no way for the state to grow stale? Well, because we're actually pulling data from the components instance, from here, right? We're actually pulling the data from the component here. Remember that this is a function that React give it to you, and it will be and it will have the latest value anytime that you call that as a callback function, right? So it's gonna provide you this. So even though it works, I don't suggest doing this, right? Or at least not for now, right? In order to truly become comfortable with React, we need to build an intuition for how effects and renders are connected. That's the whole point of this. How effects, right? And also how stale values or state setter callbacks, but in other words is use callback. Here it doesn't mention that, but callback syntax. So for example, like use effect, use memo, and use callback, right? Discussed later in this model, and also when doing asynchronous work with fetching data, discussed in the next model. Occasionally it can be more convenient to use callback syntax. For example, if we're passing the state setter function as a props to child component, we can use the callback syntax to modify the current value without also having to pass that value through props, right? Why not always use the callback syntax? You might be wondering, is there ever a reason not to use the callback syntax? And why not? But again, the whole point of looking at that you can pull data from the component state, from the components, all right, to get always a fresh value, right? And how that it relate to the effects, right? Or these callback functions, right? So you have to keep track of that. That's the whole point of this, to develop these intuitions around how effects and renders are connected. And the callback syntax can be a bit of a crutch. If we always use the callback syntax, it'll take us longer to build that intuition. But unfortunately, the callback syntax, it isn't a silver bullet. Even if you use it at all time, you'll still occasions run into situations where stale values can cause issues. And so it is important to build that intuition so that you can handle the situation as they come up. And here's what I suggest. Use the default non-callback form by default. And when you run into bugs, you can try the callback syntax to see if it helps. If it does, spend a few moments seeing if you can understand why. the more practice you get, the quicker it'll get making sense. Or I will say, the more you want to understand how the things work, the better off for you. So then I'll also look at the strict mode, right? This is again a way to guarantee that you are actually not running into use effect issues, right? Like leaving an effect running without cleaning up. For example, is adding an event listener, adding a global event like mouse move, or listen to the observer API, and not removing that event listener once you get out from that page, right? When you go to another page, that's interesting. So this is one of the useful things of a strict mode, right? So it makes a lot of sense. So it takes the use effect. It do couple stuff, right? Strict mode do couple stuff. But this was to safeguard design to amplify potential issues and warning about deprecated APIs. Okay. Warning about deprecating APIs. Unless you find yourself working in a legacy code base at least 5 years old, right? You are not likely to run into any of the deprecation warning. And again, this pattern is to see that you are actually running here. Another useful case is to create now a counter using that effect, and when you unmount the components, so you're not sure that you are actually is kicking off a timer, a new timer here. Or in other words, because this is now running any time that the component is mounted, so you have now like a long running process here. And then when this component is mounted, it removes the it clears interval. So that's good, that's great. So now I also look at the custom hooks. The TLDR of custom hooks, and why so is powerful, is because it allows us to define app level behaviors. So not only, for example, is to detect when the mouse move, or when you pass through a particular sections and do something about it using the interception observer, or to detect when you are resizing the application. Again, all of these APIs that the browser provide to us, but also is application level behaviors, right? So for example, hey, I do want to now pull data from a database, from an API, right? Which is this particular point, the data fetching. Finally, I am here, and data fetching is the critical component for most web applications. When we really think about it, in most applications, most web application exists to let user interact with data in a database. So search engines are a huge database and let us filter their billions of entries to find the most suitable result. Chat applications like Slack let us send and receive messages stored in the database. Social network provides feeds pulled from database and let us interact with them by updating data in the database. In the lessons that follow, we'll see how to send network requests in React context, right? So there's some prerequisites in order to understand that. It's like, hey, what is the difference between synchronous and asynchronous? What is a in JavaScript? What is a promise? What promise represent? Which an eventual value is it is. It is an eventual completion of a future computation, right? Whether it's on success or an error. Why do we have a sync and a wait? To actually make the code look like synchronous. But behind the scenes, what it's doing is using a generator, which is just a way of how you can get into a function execution or running a function and pause its execution by yield the computations, and then at some point in the future call the function and resume the function execution. That notion is something that is very powerful to understand it async and await, and how also I can replicate that. Well, understand how the data is transferred in an HTTP protocol, which is knowing about the verbs, about the HTTP code. 100 series is for information, 200 is for clients, client success, 300 is for redirections, 400 is for server errors, and 500 is for that's interesting. Yep. Yeah, it doesn't define that. It's just describing is the verbs. Okay. But I can is define is the different codes, codes number, right? Yeah, so 100 are for information, exactly, information response, 200 are for success response, 300 are for redirections, 400 are for client errors, and 500 is for server errors. So now it makes sense, because again, this is the way of how now these computers communicate, okay? In this client and server relationship. So, and then why we use fetch instead of using now XMLHTTPRequest, which what it does is to represent is how you can asynchronously load data in JavaScript. I actually went through that rabbit hole. I don't want to dive too much into that, but it is this. A little bit of history of that is that in the early days of the web, the only way to say data was using an HTML form tag. That's to me is mind bending. All right. But is this the HTML form element originated in 1993 with early web search engines like AliWeb, now forever gone, developed by Martin Kutzner. What Martin Kutzner is doing right now, that'll be good to know. He's a Dutch software engineer. Right? Noted for his pioneering work on internet searching, Kutzner created the AliWeb, the internet's first search engine, which was announced in November 1993 while working on Nextdoor, and presented in May 1995, the first international conference on the World Wide Web. Holy moly, May. Unlike contemporary crawler-based tools, AliWeb did not use a robot to index the web. Instead, website owners have to register. Look at this. AliWeb did not use a robot to index the web. Instead, website owners have to register their sites manually. This approach avoids the bandwidth problem that automated crawler cause. But it also limited the service growth, as many webmasters did not know how to create the required file. Kutzner also developed Archiplex, a search engine for FTP sites that predates the web on QC, a simple tool that allowed you to search different search engines in quick succession, useful in the early days of search when services provide varying results. Kutzner also created the robot exclusion standards. Oh, interesting. Interesting. Holy moly. Martin Kushner. Where is he working right now? Yeah, the robot.txt. The robot exclusion protocol often refers to by the file name used to implement the robot.txt test. It is a standard used by websites to indicate a visiting web crawler and other web robots which portion of the website they're allowed to visit. Interesting. The standard developed in 1994 relied on voluntary compliance. Malicious bot can use the file as a directory of which page to visit. Through standard bodies discourage countering this with security through obscurity. Some archival sites ignore robot.txt. The standard was used in 1990s, mitigating server overloads. In the 2020, website began denying bots that collect information to generative artificial intelligence. The robot.txt files can be used in conjunction with sitemaps, another robot inclusion standard for website. Okay, this is the standard for robot exclusion. A company was sued for accessing protected web page archive via the Webpack machine, despite robot.txt rules that prevent those pages from being archived. Okay, and here is the legal stuff here. Okay, some major search engines following this standard include Ask, AOL, Baidu, Bing, DuckDuckGo, Kagi, Google, and artificial intelligence. Starting in 2020, web operators began using robot.txt to deny access to bots collecting training data for the generative AI. In 2023, Originality AI found that 306 of the 1,000 most visited websites blocked OpenAI GPT bot in the robot.txt file, and 85 block Google extend. Many robot.txt files name GPT bot as the only bot explicitly disallowed on all pages. Denying access to GPT bot was common among new websites such as the BBC and the New York Times. In 2023, Bloghouse Medium announced it will deny access to all artificial intelligence web crawler as AI companies have leached value from writers in order to spam internet readers. GPT-bot complies with robot.txt standard and advise web operators about how to disable it, but The Verge say this only begins after training the underlying model that made it so powerful. Also, some bots are used both for search engines and artificial intelligence, and it might be impossible to block only one of these options. 404 Media reported that companies like Anthropic, this is new, Anthropic and Perplexity AI circumvent robot.txt by renaming or spinning up a new scrapper to replace the old one, the one that appears on popular block lists. In 2025, the nonprofit RLS Collective announced the launch of the Really Simple license. Open Content License Standard, allowing web publishers to set terms for AI bot in the robot.txt files. Participating companies at launch include Medium, Reddit, and Yahoo. Really simple licensing. This is new, my friend. It's an open content licensing standard that allows web publishers to set terms for web crawlers, gathering training data for generative AI. It was launched in September 10. Oh my God, that's a couple months ago. We are on we're April. 7 months ago. and is managed by non-profit RLS Collective, co-founded by RLS co-creator Edward Walther and former Ask.com CEO Doug Leeds. Participating companies at launch include Redis, Yahoo, and Medium. Publishers can implement an RLS standard by adding license terms to the robot.txt. Okay, this is one of the reasons I do in this kind of content, because it's new, it's exploration. So yeah, that's pretty much this. Okay, so initially at the beginning, right, the way to send data on the web, it was using the HTML form, right? This is an HTML tag where you now is submit the piece of information to a server. All right, using now the actions and the methods. The action specified is the route that you want to send this piece of information. The other is the actions and methods. Hey, which HTTP verb you want to send here, right? Is I want to read data, get, or I want to actually modify, or I want to update the data, right? Or I do want to create a new one, whether it's via post or a patch, or I want to delete one, right? With a delete. So this is what it was, right? And then we have now the XMLHTTPRequest, which allow a script client, usually a program that executes JavaScript code, for transferring data between a client and a server. Here is an example, and you need to specify is what is the data that you want to send, and you can use this to measuring is how much data the server is sent. So you can show a progress bar using this, right? You can also promisify that, and then is the fetch API, which is a promisify way of how you can send data. Again, unlike the XML, fetch API, when you look at the spec here, fetch API is to fetch resource in a fairly simple operation. This is not for transferring data, it's for fetching resource, right? A request goes in and a response comes out, right? So numerous API that provide this ability to fetch resource are scripts, CSS cursors, navigators and beacon, self-import. So what fetch is saying is like, hey, I'm going to define is the high level fetching operations, or a fetching, a high level fetching a resource in a fairly simple operation, right? So this is why you don't see, and as you can see, this is how it looked like. The referee upgrade insecurity request. This is why it is important to look at the source of this. This is how the URL scheme look like, redirects, cross-origin semantics, CSP, fetch metadata, service worker, referee. So you can see who actually are triggering that fetching. All right. This is part of the preface. If you look at the XMLHTTPRequest, right? It's it's a standard for defining an API for transferring data. Okay, so that's the subtle difference here to understand is the history of fetching data in simple web applications, right? So we have three ways so far. The old trusty one, which is the HTML form, the XML HTTP requests, right? Which is for transferring data. And then you have now the fetch resource, which is a way of you can to simplify to provide an API for simple fetching operations, right? And some of those involved is, for example, networking or import self, right? No, not like this. An import self, right? Import self. What is this? So self imports, right? JavaScript API, the fetch standard provides a unified architecture. The fetch standards also define the fetch JavaScript API, which expose most of the networking functionality at a fairly low abstraction, right? But the whole point of this fetch is to provide now an API for fairly simple operations, right? So whether it's image and script elements when they need to fetch resource, right? Or for self import, or even for fetch API, JavaScript API. Makes sense. So with that, right? How do we do that now here on React? You know, and it turns out that there are several tools to do so, right? Whether it is React Query or SWR, but those are the most common one, right? So once I look at this, also the test API, we're gonna hit that. So once I look at how can I fetch data on event or on mount, right? And some of the gotchas with async and events. So fetching data on an event is, for example, when you have a form and when on submit, you now trigger is the fetch API, right? And you describe now what is the data that you want to fetch, all right, or to send over. In this case, I mean, it's like the data that you want to send over, right? For example, using is a form for that, right? And when you submit that, hey, well, let me now use a fetch API to send these pieces of information to this server, to this URL, which is a server, right? And this is the option here. This is the HTTP verb, and this is the body. But since the body needs to be sent over as a string, I need to parse that into a string. This is what you can send is, for example, only you can send in serializable data, right? So for example, like that plain data values, primitive values, object values, and so on and so forth. So that makes a lot of sense. You can also send now functions over that as a string, all right? But in any case, this must be stringified, that, right? Because you're gonna send now those string, and again, a string is just a Unicode series, or particularly here on the JavaScript, a string represent is a UTF-16 Unicode, which is a code that match to a particular symbol, right? And this code, which is an hexadecimal, right? Depend how that is depend of the symbol, it can enter into the basic multilingual plan or the astral plan. So, but in any case, right? In any case, this is how you can actually is trigger that. So you are wait for that data to be you are wait for that data to be um, so you trigger the network operations, and then you schedule that, because what Away is doing is sorry, you trigger the network operation, and what fetch is doing behind the scene is to scheduling that in the micro task queue, which is a place on the web environments, or even the no environment, but on the web. Hey, this is where I'm going to handle all of this promise like, right? And when this data is now completed on the micro task, so when the data now arrive to the browser, right? What Await is doing is to say, hey, let me get out of this function, continue to evaluate other instructions, or pause the execution. And what is Await is doing is just to pause this execution of this function, right? And once this data is available, resume the execution and assign that value to the response. But because this response comes as an object from the fetch, right? So we need to transform that into a JSON, right? Usually that's something that is fast, but again, you have to wait for that. So then you have is the data available here, right, to send over. So this is how you can now send data on event, all right, or fetching on event. Okay. So here what I'm doing is just fetching on event. I can say, hey, this is my name, right? Company.com. Hey, hello, right? And I can submit that. I don't think what will happen here. Yeah, I'm not doing anything here. I'm not setting as a stay here, or let me see on the console. I already received that exactly. Hey, data received, email and message, but I need to update is the UI here. So once that is done, right, I can say is, hey, let's go into now. So you can get more fancy here. You can say, hey, let me define now a loading mechanism for this to actually show something while I'm sending this data and waiting for that to be completed, right? Or even just simple basic stuff like, hey, set the email, set that piece of information. So it's gonna clean that, and the same for the message, right? Right. So once that is done, you do this. So if I submit that, right, it is now clean. I can also provide some additional context or additional information here to do so. So what a pattern has worked for me really well, and when I do this kind of stuff, is to say, hey, this four-phase that happens in a network request or fetching some resource is like idle, pending. Idle is on the initial state, pending, success or an error, right? Which is what I define here. So what I can say here is that when this happened, all right, I do want to change now I do want to set the network state to pending, All right. And wherever it happens, I want to say is, if this is a success, you say, hey, this is a success. All right. Or yeah, success. Or if not, I can say set network state on error, right? And I want to provide some feedback on this, right? So whether I provide this right down here and say, hey, I do want to show the status here, or I can say something like this and say, hey, disable the property if the network state like this. So hey, if the network state is equal to pending, right? So this is true, otherwise is false, right? I can do the same for this to say, hey, disable, hey, if the network state is equal to pending. All right, well, this is true, or the word this is false, right? And then I can say, hey, earlier that at company.com, hello there, right? I can also add the button disable, so it prevent me some race condition. Okay, to say, hey, disable, it'll be when you trigger the network state, again equal to pending, true or false, right? So if I do this, layer at company.com, hello, right? It's interesting. Wait, what? Why it doesn't disable that input? Oh, disable, that's right. So if I go again, say, hey, hello there, submit, and now it cleans up. I can actually provide some feedback here to say, hey, your message was sent. So I can say, hey, if the network state is equal to success, hey, show this, right? Show is a H3, for example, a heading, and say message sent, right? Or if the network state is equal to error, I do want to show something like this. I can be more explicit and say, hey, show this or show this, right? Again, an H3, and say, hey, oops, something went wrong, right? And if you try this and say, hey, layer at company.com, hello there, and if I want to say, hey, throw me now an error on the endpoint, right? I think that this is on error, something like that. So, but in any case, I just want to test this on success, right? And say, hey, message sent, right? But again, a very simple, basic stuff, but this describe is the process of fetching data on an event, all right, and then fetching data on mount, okay. And yeah, and here's a final solution. Exactly, you can set that as it is. You can also set that if it's this, right? You also want to be more clean about that errors and so on and so forth. But you get the idea here, right? So yeah, that's pretty much on fetching on event. The other is fetching on mount. And here there's some couple problems that happen here. So for example is that there's a very common issue when you on the initial view you want to fetch data, right? But sometimes that data is now so that data grows stale, right? So for example, like temperature, and a temperature can change over time, okay? And this is a very surprisingly thorny problem, right? So because you need to do couple stuff. First is to how you're going to make sure that you always get the fresh data from the server, and how you can now validate that data, right? So it turns out that tools like stale while revalidate, or SWR, or GraphQL, or Apollo client, query client, or React query actually addresses this kind of issues here, right? So when the data actually grows stale, or in other words, where you want to now run, when you want to avoid that, and there's some two scenarios here. So whether on this page initially load, all right, and when something happened, I do want to render, or I want to reload or revalidate that data. That's what the names come from, stale while revalidating. So when something else happens, in this case, when I flip from one tab to another, so now I do get the data. That's quite interesting. Yeah, that's quite interesting. And this is a very surprising turny problem. So so if you want to fetch some data here, all right, use a stale while revalidating. This is known as the custom hook. If you remember for previous video, it's like, hey, oh, that makes a lot of sense, because this is what gave us the ability to this was give us the ability this would give us the ability to have this behavior in our application. That's what this custom hooks at the end of the day is all about. Hey, we have now this custom behavior application, which in our case is say, hey, when the page is initially mounted, or when somebody flip from one tab to another, or when someone goes away, when someone goes back, when someone goes back to the tab, I do want to do something here, right? So I'm passing is a fetch, I'm passing is the function. I am responsible for the fetching logic, right? But all the internal behaviors of when this function will be called, it is handled that for this for that custom hook. So in other words, here I can say is this. I can now update that type of data is equal to number, and if that is a number, all right, okay, let me show now is the temperature here. So for example, if I If I go to this tab and go back, you see? Now it updated. This is a very interesting behavior.
So I recognize there's a lot going on here, but fear not, we're going to walk through how all of this works. The first thing on line 2 is we are importing this custom hook called useSWR from the SWR library. And I'm so excited about custom hooks because they make things like this possible. It's not only useful for ourselves, right? If we have some bit of logic that we've written, we can wrap it up in a custom hook and then reuse it. We can also grab third-party custom hooks, right? Custom hooks that other people have written. And in this case, I expect the team has spent hundreds.
And when you talk about custom hooks, remember there are now some app-level behaviors that we can have in our applications.
Hundreds, if not thousands of hours building and optimizing and battle testing this hook. And so it's really cool that we get to import it and use it in our code like this. And the way it works is that we call the useSWR hook and we give it two things. The first thing is a key. This is meant to be some sort of unique identifier for the particular API route that we want to make a request to. Unless you're using GraphQL or doing something kind of funky, you want this to be the endpoint itself, right? The location that you want to make the network request to. The second thing we give it is a fetcher function. And here we hit probably the biggest misconception around libraries like this. I think people think that if you use a tool like SWR or React Query, that it totally abstracts over the data fetching process and it manages all of this stuff for you. When in fact, as you can see, we're doing a lot of the same work we were doing in the previous lesson when we were making a request without any sort of library. Tools like SWR are meant to be agnostic when it comes to the actual process of fetching data over a network. So you can use Fetch or Axios or any tool that you like for actually making the request. The difference is that we're packaging that stuff up in a function and we're giving this function to the library. And so useSWR is going to decide when exactly to call this function and what to do with the returned value. Now in this case, we're making a request to the endpoint, getting it as JSON and returning it. And so whatever I return from this function, in this case, this JSON object, will become the data variable inside this object that we get back from calling this hook. And we can see in the console, we have an example. We have OK set to true, and we have temperature set to 19. By the way, I should say, I didn't really build an entire backend weather API that knows real temperatures.
Makes sense.
So this
Makes
is
sense.
a random number.
Yeah.
It's meant to be a number that is realistic in terms of temperatures here on Earth in Celsius. But yeah, just know that we're not literally fetching your local temperature here. Once we get that data, we're getting it as the data variable from inside useSWR, and then we're using it to control the rendered output like this. And so if we think through the entire flow, this component mounts, we call the useSWR hook with a unique key and a fetcher function. SWR is then going to call this function, and it's going to provide the key as the first parameter. Now this might look a little bit silly, because this variable and this variable are the same. They're both this string right over here. And so I could just as easily not have a parameter and use this kind of all caps hard-coded endpoint within here. We still get the exact same result. The reason that it's generally preferable to do it this way is that it keeps this function being really generic. It isn't tied to this specific endpoint. And as a result, I can keep this in a helper file and import it whenever I want to make a new request all over the application for all sorts of different endpoints. Inside this function, I make a request to the specified endpoint, I get it as JSON, and I return it, which populates this data variable with whatever was returned from that endpoint, and then I can use it in my JSX. Now I know that this seems like an awful lot of trouble. It may not be clear what the benefits are to using a tool like this. And there's quite a few, but to talk about one, in fact, we're going to talk about the one that it is named after. SWR stands for Stale While Revalidate, and it refers to an HTTP caching strategy. The idea is that after a certain amount of time or after certain things happen, this data might grow stale, right? The page loads, I see the temperature is 28 degrees, but if I spend several hours on this page, well, this probably isn't the right temperature anymore. And let's suppose I change tabs and I'm doing something over here, I'm gone for a while. When I come back to this tab, it's probably a good idea to fetch new data. And so if we wait a minute, we see that it does indeed update this value. And again, these are randomly generated numbers from the API, which is why we see it changing. But it's the act of switching tabs and coming back that triggered that revalidation. Now you'll notice we don't see a loading spinner or anything else like that while it's fetching new data, because it chooses to show the stale data. That's why stale while revalidate, right? We're revalidating the data, but while we're doing that, we're keeping the stale data so that the UI always shows something. This is exactly the sort of problem that gets really annoying if you try to solve it by yourself in terms of when should I do this, right? What are the heuristics I should use to control that? And granted, the library does make a lot of this configurable, so you can choose exactly when you do and don't want this to happen, but it's just really nice having a library that manages all of this complexity for us.
But that's the whole point of this, right? And then we have now several exercises to actually describe how can we pull this data and simulate those environments. Okay. I'm not gonna go into that, despite that I can. I just want to describe what is the things that we can do here. All right. And how can be quite convenient sometimes to depend on the network success, what is the results that we want to show here. So if I go here and say, hey, there is an error at line 35, you don't have encoding here under the endpoint search term, right? Search URL, you say, hey, identify search URL has already been declared. Oh, that's interesting. Yeah, you're right. But the point of this is to show something. Exactly. Whether it's you're gonna show this. Yep. Like this. All right. Or not, on idle and on error and on loading and then on the success. So if I search for something here, let's say for A, searching, now it's gonna show all of these different books, but this particular pattern is something that you're gonna see a lot of the time, right now we're using is we're not using is stale while revalidating. This is a just simple exercise to go over that. And the other is using now stale while revalidating here, right? It say that this is an error here at line what it is, line in the use car here, because it say cannot read property of undefined reading name. You are right. So what I can say here, if that hey, if data exists, right? Okay, so let's go into so if data exists, so if data exists, this won't fix the issue, because it say, hey, I do not have is the this is an unexpected token. Yeah, that's right. Error, this request returns an error because the simulator error query parent was specified. So I can say, hey, that's good. I can hold this to say, hey, this is endpoint error, right? Just to simulate that, you know, endpoint simulate error, right? So as you can see, actually I'm pulling the data here and show that if we have that, right? We can also say, hey, you can remove this, get rid of this, and just tell to this component, when this component is mounted, it's gonna call this custom behavior known as stale-well revalidate, and providing is the endpoint, which is here, as well as the function that this custom hook is gonna call for me, that say, hey, fetch this data, and now schedule that into the micro task queue. So once that data is available, now put that on the call stack. So the event loop is gonna detect that. Once the data is available, it's gonna put that from the micro task to the call stack, and now resumes execution here on this function, inject that value, and assign that to the response, and continue to evaluate this as a normal JavaScript function. And it goes down here and they say, hey, now I need to wait for the response.json, because I need to transform this response that coming as a streams of as a raw stream binary, and I need to transform that into something that the application can use, right? For example, like JSON, and then, all right, so for that, well, this is a process that I also need to schedule without blocking the main thread. And once that is done, so once I convert all of these streams of bytes into a JSON, all right, you're going to have that data here, right? And then you can actually continue to evaluate that and return the data as a user, or the simple data as it is. Okay, so now in the case that you have the data, it's going to continue to look, it's going to evaluate, it's going to print the data at that moment. If you have that, if you don't, so if you have that, right, it will now skip this because we don't have any errors, and it will show now the component, which is a React element, that it is defined here in the use card, that when I look at this and say, hey, this is a component that is going to render now an article that has is 2 paragraph with the class name of name, and pull this data here, and the class name of email here. And once you call this function, I do want you to transform each one of those paragraphs into a React element, and call those functions that describe now the state of the application at this function, right? Where now, when that change, the name or the email, I'm going to update the content properly here, right? So if we run this again, it said that this is an error here on the app component. Consider error boundary. Wait, what? Cannot read name. Cannot read property of undefined reading name. That's interesting. The reading name, data.name. So if I reload this, Still get the same error. Okay. This is okay. Okay. Cannot read property of undefined reading name. Reading name here. Reading name. The reading name. Reading name. Right? So it seems that initially cannot read property of undefined reading name. At which line? Yeah, it doesn't specify the line. But is this is on return. Use car. That's interesting. And it continued to throw me this error. Okay, so here is evaluating this. I'm getting is the data, and here somehow it reached to this, but it say, hey, the data.name and the data.email, it say I cannot read property of undefined, which is kind of odd, right? Because if I say this, so if data exists, please show this. Okay. So if you have some data, show it. Okay. Okay. This is the behavior. Okay, makes sense. This is a behavior from this from here, because initially when this is being called, it doesn't have access to the data name here, but on the subsequent render it does, right? That's what happened here, and it makes sense, makes a lot of sense, right? So if I want to render now here with the error, I can say it's gonna do some concatenation here, right? And it show is this error, which is error. This request returns an error because the simulator error here. In fact, it's not showing something, right? So if I reload this, is error. Oh, okay. 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 So if I say error here, error is undefined. That's quite interesting. So in this case, I must do something like this: data.error exists, something went wrong. Okay, that's, yeah, but this is more because narrow specific. This is more specific to the custom hook for that, so that's great. Good, awesome. Yep. So that's the whole point of data fetching here. Okay, it's not error. This is also why it is quite useful to use TypeScript, so you can see the shape of the data here, and you don't actually try to do that by your own, right? But is this, or you can also yeah, just render something like that.
So the first thing I'm going to do in this one is create a brand new async function call.
But that to me is quite interesting because doesn't, yeah, is I don't know how, but again, this is the accepting criteria, right? And I need to show is a spinner for that.
Called fetcher. It's going to receive endpoint as a parameter, and it's going to do all that boilerplate stuff we've been talking about, where I make a fetch call to the endpoint, and then I turn the response into JSON. Finally, I am going to return that JSON. This function is going to be used when we call the useSWR hook. First, I need to pass it the endpoint that we're requesting from, and then it needs the fetcher function. This hook will return an object, and that object will have a data property and an error property, and so I'll destructure those properties from the hook. And now if I log both data and error, we can see what we get. We see that we have undefined for the error, and an object with an OK property set to true, and a user property set to a randomly generated user. And so I'm going to use that information. I'm going to check to see if we have a data.user. And if we do, I'm going to move
You're
this
gonna
user
render
card up,
is that.
and I'm going to swap out the placeholders so that name will be set to data.user.name, and email will be set to data.user.email. Now this looks pretty good. I do see that I'm getting the random user card, but if I refresh the page, I see that we have a problem. And I don't know why. The actual error doesn't show up in this little console, but if we open the browser DevTools, we should see the actual error, and the error is cannot read properties of undefined, reading user. The reason this is happening is that initially, for that very first render, data is undefined and error is undefined. These variables are only populated once this code has had a chance to finish running. It actually reminds me quite a bit of refs, where refs are also undefined until after the first render. For now, I'm going to solve this by using the optional chaining operator. So if we don't have data, well then we just won't do any of this, and instead we'll wind up with a blank screen at first. I guess actually that's a good indication that it's time to add some sort of loading state. And so I'm going to say is loading is equal to not data and not error, right? If either of these exist, if either we've returned some JSON that we want to use as the data, or we've hit some sort of snag, we've thrown something, and the error value has been populated. If either of those things are true, we're not loading anymore. But until that is the case, we will be in our loading state. And for loading, I'm going to return a spinner. If I refresh the page, we should see a brief moment of spinner before things load. The last thing to tackle is the error state. And this one in particular can be sort of counterintuitive. First things first, I need the backend to provide an error, and so I'm going to add the simulated error query parameter. When I do that, if I look at my logs and I'm still logging data and error, error is still undefined, and now data is this object describing the error. The reason I say that this is counterintuitive is that I know by adding this simulated error flag that the server is providing a 500 status code, right? The universal signal for something has exploded on the server. And we might expect that to automatically be picked up so that as I run this code, it would populate the error variable instead of the data variable. The trouble is that SWR has no idea what happens inside this function.
It doesn't have
It calls the function,
of
and
that.
if I return something, it's going to use whatever that returned value is as the data. To populate the error, I have to throw something instead of returning something.
That makes sense.
So here's what I'm going to do. If JSON is not okay, right? If JSON.OK does not exist, because it doesn't exist in this object, but it does exist in the happy path response, then I'm going to throw JSON. And so if I refresh this page now, what I notice is that data is undefined and error is now this object with the error property. It's a good reminder that SWR does not actually manage the network request stuff. It manages everything around that, but we're still the ones making the request and deciding what counts as a success and what counts as a failure. Now that we have the correct values being populated over here, we can add our error state. I'll add an if error check, and if that's true, I'll return a paragraph that says something went wrong. With that done, I see that we transition from our loading state to our error state. That one was really quick, but I did see it for a second. And if I remove this query parameter, we should see transitioning from loading to the happy state, and indeed we do. Stick a fork in this solution, it's done. So the first thing I'm going to...
When I filmed this video, SWR didn't yet provide its loading value. This is a relatively new feature as part of the 2.0 release. I have updated the solution code for that, so that's what it is. So it already provides you that functionality here. And then you look now at the async effect gotchas here, especially on the use effect and why we don't provide an async here, and why we need to is provide or why we define is the async not as passing as a callback to the use effect, but as inside of here and executing that asynchronous operations. For example, like this, right? Hey, do you want to actually run this asynchronous task to be scheduled by the event loop at the micro task queue? All right. So pass the callback if pass the so pass the callback function to the effect without the async and await. You just only want to schedule this your async operation inside of those async callback here. Mm-hmm. So yeah, that'll be all for this video. Take care. Bye bye.